we have yet another example of the properties of exponents. Thanks for joining us. All right. Whoa. Am I supposed to do 77 to the 8th power or 15 to the 8th power? How am I supposed to do any of these? Guess what? We have some creative tricks up our sleeves. We see these numbers with exponents, and to figure them out would be way too much. But we can break them down first. 77. Well, I can find some numbers that multiply to 77, right? So 77 is just 7 times 11. How can I use that? Okay, 7 times 11. I'm going to replace 77 with that. Oh, to the 8th power. Great. I can do that again over here with 3 times 5 is 15 to the 8th power. All over the denominator here is 3 times 11 to the 8th power. And 35 is 5 times 7 to the 8th power. Whoa! Look at all of these power of powers properties waiting to happen. So many distributings. So 7 to the 8th times 11 to the 8th times 3 to the 8th times 5 to the 8th all over 3 to the 8th times 11 to the 8th times 5 to the 8th times 7 to the 8th. Whoa! Now we hopefully see a lot of things happening. It's really kind of the quotient property, but we also can kind of just think of canceling them. A 7 to the 8th and a 7 to the 8th. I mean, 7 to the 0 or 1. And we see the same thing happening with all of the other numbers. 3s, 5s, 11s. You're all gone. And our final answer is just 1. Wasn't that awesome? Didn't that feel so satisfying? Who would have saw that? We could have never done 77 to the 8th power. Well, never, but it would have been hard. It would have been hard. So, powers of exponents, properties of exponents helped us for sure. Will this next one be 1 as well? Stay tuned. Let's take a deep dive into this. So, 50. Let's do the full factorization of this as 2 times 5 times 5. And it's to the 5th power. And 9 is 3 times 3 to the 4th now. Okay, denominator, we have 3 times 5 because that's 15 to the 7th power, and 2 times 3 is 6 to the 4th power. Great. Now, we could distribute the 5 to everything in here. So we're going to get 2 to the 5th, but when we look at the fact that we have 2 factors of 5 here, 5 times 5 is 5 squared. And if we think about, we can write it off here. 5 times 5 is 5 squared. Oops, that should be a 2 up there. Oh, no. Okay, so 5 times 5 is 5 squared, so that's really 5 to the 10th. Okay, makes sense? Thanks. Sorry for the goof there. All right, 5 to the 10th. Over here, we have 3 times 3, which is 3 squared to the 4th. 3 squared to the 4th. So that exponent of 2 and exponent of 4 makes exponent of 8. Okay, denominator. We have 3 to the 7th, 5 to the 7th, times 2 to the 4th, 3 to the 4th. Whew! So much happening. Okay, let's look for anything we can combine. In the numerator, I don't see anything. I'm going to put them in order from least to greatest in terms of bases. So 2 to the 5th, 3 to the 8th, 5 to the 10th. And the denominator here, 2 to the 4th. Now I have 2 bases with 3. So that's going to be 3 to the 11th power and 5 to the 7th. Okay, so quotient property says subtract our exponents with the same base. So 2 to the 5th over 2 to the 4th leaves us with just 2 in the numerator. And if we have 8 over 11, we have 3 to the 3rd in the denominator. And we're going to have 5 to the 3rd in the numerator. So that's going to be our final answer. Oops, sorry, that is a little bit down off your screen. Let's see if we can make this more visible to you there. All right, numerator, though, is 2 times 125, or 250, and the denominator is 3 cubed, which is 27. That's our final answer. Wow, that was fun. Thanks for watching. Check in for more examples in other videos.